your medication or your intervention, the number of patients alive at each calendar year after the initiation of that treatment. So if you want to calculate the probability of surviving each year, your probability is equal to the number of patients alive at the end of time period X divided by the total number of patients who started treatment in time X. So again, we'll do it together. Okay, so here you have 5 years of treatment, and it tells you how many patients were treated in each year. Then it tells you the number of patients alive at the end of the year in columns for the first year through the 5th year columns. Excuse me. So you want to know what is the probability of surviving the first year? And so if you look back at the previous slide, you're looking at the number of patients alive at the end of the time period, which is year 1, divided by the total number of patients who started treatment. So what is the total number of patients that started treatment after the 5 years? 375. So all of the people alive at the end are in your numerator, and all of the people who participated are your denominator. So what is your probability of surviving the first year? 0.525. Okay, now you want to know the probability of surviving the second year. So this is where folks get tripped up, right? Because it tells you here how many people were alive at the end of the year. So the folks who were alive at the end of the year are 43. And so 197 minus 43 is now going to be your denominator. So again, go back up if you're getting confused. Number of patients alive at the end of time period X, 71, right? These are the number of people that are alive at the end of the second year. And the total number of patients who started treatment in time X. So the total number of people who started treatment, right? So 197 minus the 43, which then your probability of surviving to the second year is reduced. And again and again. And you can see you can actually calculate the probability of surviving the 5th year, which is 0.8. So if you make it through to the 5th year, your probability of survival after that is pretty good. So then we look at cumulative probability. And basically you're multiplying the probabilities so that you can figure out the probability of surviving different lengths of time. So this one was a standard, right? That was that first one. Probability is 52.5%, so about half. Probability of 2 years, you're multiplying the probability of the first year times the second. It's very easy to misinterpret this, okay? Sorry, this one. Probability of first year, probability of second. So it's very easy to misinterpret this as the probability of surviving through the second year, and that's not what this is. This is the probability of surviving the second year. If you want to do the cumulative probability, this is how you do it. You multiply the probability of the different years. So here you can see, even though it looked higher when you did it individually, when you look at the probability of surviving the total 5 years, it is actually only 8.8%. And then this is another way of visually representing what it is that you just did. Okay? So this is the cumulative proportion who survived from enrollment to the end of the interval. And this, if you are a person who kind of shirks away from representations of numbers, this can seem a little overwhelming. But again, you just follow the columns. The interval since beginning treatment. First year, second year, third year. Who was alive at the beginning of the interval? 375 people. Only 16 were alive at the beginning of year 5. Who died during the interval? 178 all the way down. Who withdrew? So this was a tricky one if you missed it. When you were subtracting, you would have come up with people with a difference of the people who were alive and the people who were treated, and that would have been your withdrawal. The people that didn't die, they just didn't participate in the study. Then your The effective number exposed to risk of dying during the interval, this is just a standard calculation, so it's column 2 minus 1/2 column 4. So if you remember your order of operations, you have to do 1/2 of column 4 before you subtract this number from column 2. The proportion who died during the interval is column 3 divided by column 5, who died, divided by the number exposed to the risk of dying. So if you remember that, if you remember your incidence, the denominator was those who were at risk, and so this is a similar proportion. A proportion who did not die during the interval is just 1 minus column 6. And then your cumulative proportion who survived, I like to tell folks that this is a Z. So here, let's do it together. So if you were watching, you're multiplying the first number by the proportion who did not die, and that's how you're getting your cumulative proportion. Then you multiply this number by, you multiply column 8 by column 7, you get this number. You multiply this number by column 7, you get this number. So that's why I say it's a Z formation. And so you want to know, what is the cumulative proportion of people who survived from enrollment to the end of the interval, the end of the 5 years? This is your cumulative survival. It's only 0.124. 0.124 of the folks who started survived. So you can kind of make decisions about how successful this trial was if you started with 375 patients, and at the end only 0.124 were alive, and you can see that number here. Only 8 people were alive of the 375 that started. Just 8 people. All right, so again, prognosis and survival is another, it's built upon the skills from the previous 2 weeks. So if you're having trouble, with your order of operations and the basic math concepts, or if there's still something like, why are we talking about person time? Well, we talk about person time because we talk about incidence density in lieu of incidence rate when we cannot observe all individuals in the population. So those kind of questions, if information is still kind of like not sitting well with you, I need you to send me an email when we have these online sessions, because otherwise I'm not aware of where you may be getting stuck and where to emphasize in the next lecture. All right, thank you.